Okay, so maybe you were the person who got mad when you started doing algebra and they started putting variables in, when they started using letters in math, and maybe you said, there should not be letters in math, there should just be numbers. Well, if you were that person, if you got mad with that, you're really not going to be too happy with today's lesson, all right? Let's look at it and you'll quickly see what I mean. I want to know the square root of -9. And maybe you recognize what the problem is here, but I want to show you. So I've got the square root of -9 here. And when I go for an answer, it says math error. Well, what does that mean? You know what math error means. By this point, you understand math error means there's no solutions to it. But why? Well, let's look at this. Let's just say that we took the square root of +9. If I want to know the square root of +9, that's just going to be 3. And why is that? Well, that's because 3 times 3 equals 9. Okay? 3 times 3 equals 9. Well, what about the square root of -9? It'd be very tempting to say that the square root of -9 is -3. But is that true? Does -3 times -3 equal -9? No, it doesn't, because a negative times a negative equals a positive. This is also +9. And we can't say -3 times +3 because that's not what a square root is. A square root has to be the same number. So you can see we have a problem. We can never square something, multiply a number by itself, and get a negative answer. At this point, you probably say, well, this is fantastic. I don't know why you said I'm not going to like this lesson, because I can already tell this first one, you said I can't take square root of negative number. This is no solutions. And square root of -16 is also no solutions. Well, that would be true, but there's no real solutions to this. I'll give you that, but there are imaginary solutions, and there's imaginary numbers. And right now you might be maybe hating me that I'm telling you first we had to use letters in math, and now we're going to use imaginary numbers in math, but that's actually what we're going to do. Luckily, though, there's only one imaginary number, and that one imaginary number is the square root of -1. Square root of -1 obviously doesn't exist because it's a negative square root, but we're going to imagine that it does, and we're going to call that number I. All right, this is also called a complex number. So I is the square root of -1. Now, one thing to understand, I is not a variable. I is not like X or Y or Z. X or Y or Z could be any number. I is not a variable. I is always the square root of -1. So how is this going to be helpful using these imaginary numbers? Well, let's look at this. Let's simplify the square root of -9. We already know that you can do something like this. The square root of 8, that's equal to the square root of 4 times the square root of 2, right? We know that we can do that. The square root of -9, we can write it like this. The square root of +9 times the square root of -1. Okay? And the square root of +9 is 3, and the square root of -1, that's just I. So this is just going to be, the square root of -9 is just going to be 3i. Let's look at this next one. Maybe you can do this without showing any work, but this is just going to be root 16 root -1, and root 16 is just 4, and the square root of -1 is just I. So the square root of -16 is just 4i. So that's pretty easy when we're doing it like that, but what if we get some operations here? What if we're going to add them together? Well, at this point, we're going to kind of treat and think of I like a variable where we can combine like terms. So since this is a plus, all we have to do is combine like terms. We've got a 7 and a 3. That's going to be a 10. Then we have a +4i and a -6i. So that's going to be a -2i. So not bad. Let's look at this next one. Same thing, but be careful. Remember what you have to do when you're subtracting. It's like distributing a -1 to everything, or you can just think about changing the signs. So I'm going to change this to a plus, change this to a minus, and change this to a plus. All right? So that's algebra 1. We should remember how to do that. Let's combine these like terms again. I've got a positive 12 and a negative 14. That's going to give me a negative 2. Now I've got a negative 6i and a positive 7i. That's going to be a positive 1i. Just like a variable, I don't need a 1 out in front of it. That's just going to be negative 2 plus I. What happens if we multiply these? Well, again, think of I as a variable-ish. It's not a variable, right? But let's use the same rules for it. 9i times 4, that's just going to be 36i. And then 9i times 2i is going to be 18i squared. And this is a tricky concept to understand, okay? Watch this. Let's come back to the blue over here. If I is equal to the square root of negative 1, then I squared is equal to the square root of negative 1 squared, right? Square both sides. That makes sense. Well, what do we know about the square root of a square root when you square it? A square root and a square will just cancel. So I squared is actually just equal to negative 1. So I is equal to the square root of negative 1, and I squared is equal to negative 1. So if I come back up here where I have an I squared, I know that's just negative 1. So what's 18 times negative 1? That's negative 18. So I have 36i minus 18. That's what that is. Let's look at this next one. 3 times 8 is 24. 3 times negative 5i is negative 15i. Then let's go to the bottom. 4i times 8, that's going to be plus 32i. Then 4 times negative 5i is negative 20i squared. Time to simplify. 24. Combine the i's. Negative 15i plus 32i is going to be positive 17i. And what about this negative 20i squared? Remember, I squared is negative 1. So we have a negative 20 times a negative 1, and that's going to be a positive 20. And now look, we just have a couple more terms that we can add together. So this is going to be 44. 24 plus 20 is 44, plus 17i. I know that one was tricky. I know that one was tricky. Let's do the next one. 6 times 9 is 54. 6 times 4i is 24i. That's not too bad. How about the 7i? 7i times 9 is going to be 63i. And 7i times 4i is going to be 28i squared. So we have 54 plus our 24i plus 63i. That's going to be 87i. And then the I squared at the end, remember, I squared is negative 1. I squared equals negative 1. So I've got 28 times negative 1 is going to be a negative 28. Then combine your like terms again, simplify this. 54 minus 28 is going to be 26 plus 87i. All right. Now, I know it can be kind of mind-blowing that now we're working with numbers that don't exist. But as you can see, and there's going to be some times where this will actually work out to be a real number that we'll get for our answer. So there are times that this is useful, and hopefully you'll be able to navigate this through. So when we're working with them, think about it kind of like an exponent in as far as the mechanics go and how they work. But just remember that I is always negative 1, and be very careful. Watch for those I squareds, because when it's an I squared, all of a sudden that's a real number. I squared is negative 1. So if you have an I squared, just remember to substitute in a negative 1 for that, okay? I know you can do this. Good luck.